Welcome to the next tutorial on electricity. From this tutorial, I will be discussing the solutions to the problems which I mentioned in my previous video. The first problem is the resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? Okay, let us first find out what are the things that is available. We know the resistance, which is 26 ohm at 20 degrees Celsius. We know the diameter of the metal wire, which is 0.3 millimeter. And we also know the length of the metal wire, which is 1 meter. And we have to find the value of rho. Now, the formula is R equal to rho into L upon A. Now, therefore, rho equal to R multiplied by A upon L. Now, here I have a problem. I do not have the value of A. All I have is the value of the diameter, which is 0.3 millimeter. So, I have to calculate the value of the area of cross section. For that, I need to know the radius, which is diameter by 2, that is 0.3 upon 2 equal to 0.15 millimeter. Therefore, area of cross section A equal to pi into R square. Pi is 22 by 7 and R is 0.15. Okay, let us cut it out. There is a reason. 0.15 is in millimeter. So, we have to find it out. What is the value of this in SI unit, that is meter. So, divide by 1000, which gives the value in meter. That means 0.15 upon 1000, which is 10 to the power minus 4 multiplied by 1.5 meter. So, this is the radius in SI unit, that is meter. Therefore, area of cross section A equal to pi R square, which is 22 by 7 into 1.5 multiplied by 10 to the power minus 4 whole square, which is equal to 22 upon 7 into 1.5 whole square, 1.5 into 1.5 into 10 to the power minus 4 whole square, which is 10 to the power minus 8. Therefore, it is 22 by 7. Let us write it up. 22 by 7 into 1.5 into 1.5, which is 2.25 into 10 to the power minus 8 meter square. This is the area of cross section of the wire. Now, we can calculate the value of rho. Therefore, rho equal to resistance, which is 26 ohms, area of cross section, which is 22 upon 7 into 2.25 into 10 to the power minus 8, and length is 1. Therefore, rho equal to 22 by 7 is 3.14 into 2.25 into 10 to the power minus 8. Now, 26 into 3.14 into 2.25, which will be equal to 183.69. into 10 to the power minus 8 ohm meter. So this is the value of resistivity of the metal at 20 degree Celsius. So let us write the answer. Okay, so this is the answer for the numerical problem number 1. Now let us look at the problem number 2, where the wire of resistance 20 ohm is drawn out, that means it is pulled, that is stretched, so that its length is increased to twice, that means length will become double, and we have to find out what will be the new resistance. So let us see if we can find out exactly what is happening here. So let us draw a piece of wire. So this is a piece of wire. Oops, there is a problem. So this is a piece of wire in the original condition. Next we pull it to increase the length. So when you pull the wire, since the amount of material is remaining the same, the wire will become thinner. That means length will become double. So when the length of the wire becomes double, definitely its area of cross section will become half. Okay, because the total volume of the wire still remains the same. So when the length is double, the area of cross section of the wire becomes exactly half. So if the wire is drawn to double its length, its area of cross section will become half. Will become half. So this is the most interesting point of this solution. So now let us see what is happening. So length will become 2L because length has become double, and area of cross section will be half. A will become half of A. Then what is the value of resistance? It will be rho into length. Length has become 2L now, and area A has become A by 2. So this becomes 2 into 2 into rho into L upon A. Now rho into L upon A is the original resistance, which is, this is the original resistance, say it is R. So resistance, that means the resistance will become 4 times the original resistance. So when you stretch the wire to double its length, its resistance will become 4 times. Now the original resistance of the wire was 20 ohms. It was given. So when the resistance become 4 times, so 4 into 20, it will become 80 ohms. So 4 times of 20 ohms equal to 80 ohms.